In the middle, number of questions will be there from my side. You must be ready to do answer. Right. Yeah, Nana. But while writing formalities, I will ask you some questions. Try to answer the question through messages. Yes, Nana. See, according to the original version of Moseley's periodic table, which period is considered as long period? Which period is considered as long period? Long period. Fast. Yeah. Vignata, so far. Tanuja, okay. Nityananda, correct. Good. Stop messaging. Both fourth and fifth periods are considered as, seen on a description. What is the description of periods? Let me write first of all. First period, shortest period with only 2 elements. Second period, short period with 8 elements. Third period is also short with 8 elements. Fourth period, long period, consists of 18 elements. Fifth period is also called long period, consists of 18 elements. Sixth period, longest period, consists of 32 elements. Seventh period, around 20 elements, described as incomplete period. Incomplete period, around 20 elements. By the time of Moseley, not today, 100 years back. Later, with the effort of human beings, with the effort of other scientists, today we are reaching towards 120 elements. By the time of Moseley, the elements were only around 100. Around 100. Number was not considered. 104, 103, like in different books. Right, Nana? So, but today, more than 20, greater than 20 elements, not 28 exactly, not 27 exactly. Sir, board is not clear. Okay, Nana. Almost we made it clear. Wait. But from our side is clear. The problem may be from your network side. Yes. See, one more question. Yes, Nana. There are how many vertical columns in the original form of Moseley's periodic table? In the Moseley's periodic table, how many vertical columns are there? How many vertical columns are there? Nityananda, I am asking vertical columns. Osho, correct. Bharat, not. Your answer is the Jayant, correct. Abbas, somebody 17. Stopped at 17. Tezdeep, okay. Correct, ma? Sunil, Ganesh Kumar, not correct. Stop messaging. See, 18 vertical columns. 18 vertical columns. But in the original form, not 18. That is why I changed the word original form. But today we are following 18 vertical columns. Yeah. Each vertical column is called group. That means 18 groups today we are following. But in the original form also, 18 vertical columns were there. But number of groups were 16. Number of groups were 16. 18 vertical columns were there. Groups were A and B subdivisions. Groups were with A and B subdivisions. But today in around 2000, around 2000. IUPAC, not around 2000, actually it was happened before that, around 1992. According to the initiation of IUPAC, subdivisions were lifted, subdivisions were removed. And after 2000, it was made it clear, subdivisions were removed. Even in the recent publications of NCERT books, subdivisions were removed. Just group numbers now we need to follow. First group to 18th group. Group number 1 to 1, 2, 3, 4, 5, 6 dash 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 up to 18th group. 18th group. Okay, Nana. All these things are there in the volume or in some other book. But now our point is, see, yesterday I explained you the design of Moseley's periodic table and how did Moseley get the design. With reasons I explained you yesterday. But today it's my duty to take ahead the matter. To take ahead the matter. Today is my duty. So, as a part of that, let me explain the divisions of periodic table, modern periodic table. See, divisions in the modern periodic table. Thank you, madam. Yes, madam. The divisions in the modern periodic table, Nana. Modern periodic table. Yeah, what are the divisions? Modern periodic table divided into 4 divisions. How many divisions? 4 divisions. Yeah. Each division is called block. BLOCK block, Nana. Each division is called block. Yeah. What are the 4 divisions? 4 blocks. S, P, D, and F. S, P, D, and F. Yeah. But on what basis? So, divisions are done on the basis of elements. Modern periodic table divided into 4 blocks. On what basis? On what basis? Can anybody tell? Okay. Can anybody tell? Modern periodic table divided into 4 blocks. On what basis? So, if anybody is ready to say, we will unmute them. Raise hand. Very good. Sanjana, similarities you are telling. No, Nana. Because of similarities, adi kuda question adugutanu. Yeah. Charan Siddharth, madam. Unmute Charan Siddharth. Charan Siddharth. Nana, welcome.
Sir, it is based on electronic configuration, sir.
Very good. Your friend also has sent a message. So, it is based on electronic configuration of the elements. Yes, ma. What is the, that means main point in that? Okay, electronic configuration. Very good. Your answer is good. It is based on the electronic configuration of the elements. But how do we decide? Yes, hydrogen, it has 1 electron. You can write hydrogen 1s1. Nana, S-batch students, don't feel fear about the topic. Listen carefully enough. You can also understand slowly. Right. 1s1, helium 1s2, and lithium 1s1, 1s2, 2s1. అన్నిట్లో 1s1 ఉంది కదా, మరి ఎలా డివైడ్ చేస్తావు?
Sir, the elements which have like up to which orbital they have electronic configuration.
Yeah, my question is based on which electron? First electron, middle electron, last electron. So now, if you take beryllium, beryllium belongs to S block. How do you say? Based on first electron, based on last electron, based on middle electron. Vignata has answered. Abbas also has answered. Charan Siddharth?
Sir?
Based on, see, now let me say beryllium. See, nana, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Beryllium, boron, beryllium, magnesium, calcium, strontium, barium, radium. Kada? Right. Now I'm telling you, beryllium is, yes, I have written all these elements are S block elements. Which block elements, ma?
S block element.
How do you say beryllium is S block? అంటే నేను చెప్పాను కాబట్టి
Based on
చెప్తానా?
last electron, sir. Based on
Last electron. Your friends also have sent the message. See, if you write electronic configuration of beryllium, it is, the electronic configuration of beryllium is 1s2, 2s2. That means last electron enters in which subshell?
S orbital, sir.
S orbital. So that beryllium belongs to which block?
S block.
That is the reason, Nana. Okay? Good. Good, ma. Yes. Make mute yourself, ma. Yeah. Yes, block. So, like that, if you write the electronic configuration of potassium or calcium, I am writing. See, calcium, atomic number 20. That means 20 electrons. Calcium atom has. Those 20 electrons are distributed to different energy levels, different shells like this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Nana, yes, batch students, listen to me carefully. What does it mean? Calcium electronic calcium atomic number 20. Everyone knows it. Its atomic number 20 means it has 20 electrons in its atom. Okay? Yes. Those 20 electrons, how are distributed? How are distributed naturally? We did not distribute the 20 electrons. How are these 20 electrons distributed? Naturally, distribution was happened like this. 2 electrons in the s orbital of, Nana, all of you be attentive. This is very, very, very important explanation here. Everyone must be with 100% attentiveness. 2 electrons in s orbital of first shell. Then 2 electrons s orbital of second shell. 6 electrons p orbital of second shell. 3 electrons s orbital of third shell. 6 electrons p orbital of third shell. And finally, 19th electron. About calcium means, let it be potassium, no problem. Potassium 19 gada. Go to 19, potassium. 19th electron enters. 19th electron enters s orbital of fourth shell. This is called last electron. based on the last electron, based on the entry of last electron, the last electron enters which orbital, the element specified element is called element says belong to that block. Element says belong to that block. Okay, based on the entry of the last electron. Understand? So this is called the last electron in each and every atom, which can separates it from the other elements. The last electron in each and every atom is called differentiating electron. See, last electron I am writing here. Last electron of any atom is called differentiating electron. Differentiating electron. Differentiating electron. Okay. So based on differentiating electron, elements are divided into blocks. Elements are divided into blocks. Okay. So elements divided into 4 blocks. S block, P block, D block, and F block. Okay, Nana. Now, please write one thing. I would like to tell you one statement. All of you note down in the notes. This is only for example. Idi kuda raskoval Nana. Divisions in the modern periodic table. Okay. So whatever I have written on the board, note it down. ఇంతవరకు రాయండి చెప్తాను. Right up to here. Everyone must be there online. Why are you leaving somebody? Why are you leaving? When we ask you to write something, you want to leave, again you want to join. So all of you be online up to 12:30. After 12:30, it is your wish. More 5 minutes I will continue. That is your wish. Whether you want to be with us, want to be left. But till then, everyone must be online. Yeah. Note down this. Divisions in the modern periodic table. How many divisions? 4 divisions. Each division is called what? Block. What are those 4 blocks? S, P, D, F. Very briefly, I wrote on the board. Now, yes, how did periodic table divide into divisions? How did periodic table divide into divisions? On what basis? On the basis of, write this one, electronic configuration of elements. On the basis of electronic configuration of elements. ఇంతవరకు రాయండి అన్న చాలు. Right up to here enough. Okay. Yes, Nana. After writing this, now I will dictate. Please note down. I will tell you, Nana. I will tell you answer for you, Abbas. First of all, complete it. Note change. Only 3 lines. Divisions in the modern periodic table. There are 4 divisions. Each division is called block. Those are SPDF blocks. On what basis? On the basis of electronic configuration of the elements. Now write. Yeah. On the basis of differentiating electron, on the basis of differentiating electron of the elements on the basis of differentiating electron of the elements. Periodic table is divided into 4 blocks. Periodic table is divided into 4 blocks. Write in bracket once again SPDF. Whether you write smaller or bigger, capital letters, no issue. There is no any condition to write small, to write big. But traditionally we follow small letters, that's it. SPDF. Yeah, now write. All of you, Nana, write down. Differentiating electron, subheading. Differentiating electron. The last electron of an atom, the last electron of an atom. Okay, the last electron of an atom. Enough, Nana. Is said to be, that is common. The last electron of an atom is called differentiating electron. Now let me answer for your classmates' question. Nana, my dear Abbas, you answer to me through messages. Listen to me, all of you, and answer to me through messages. See, to learn chemistry today, after Moseley's periodic table existed, anybody wanted to learn chemistry, first of all, they wanted to be perfected. Okay. About the information of 18 groups and 7 periods. 18 groups and 7 periods. But later, because of the initiation of Niels Bohr, what Niels Bohr suggested, instead of learning 18 groups, why should not we go more simpler? As a result of that, as a result of his creative thought, he divided the elements into 4 blocks based on electronic configuration of the elements. So they got that thought, not only Niels Bohr, a group of scientists. That's why this classification is not specifically called by any scientist name, but the main pioneer was Niels Bohr. Okay, so they wanted to make process more simpler. So instead of making people to learn about 18 groups, 7 periods, they wanted to insist only 4 blocks. This is the result of they got, that means today we have 4 blocks of elements. Okay, even if you learn about 4 blocks, it is equal to learning 18 groups, approximately. Understand, not in detail, but outer area, outer information you can learn. Okay, sir, in first year book for EC of K, they also gave us, yeah, why it is, sir? Okay, Nana, see, this and all is equal to argon, Nana, Aditya. 1s2 to 3p6 is equal to argon. So this is called, whatever you observed, it is called condensed form. That means Ar4s1. Instead of writing all this, you can simply write argon and 4s1, right? Okay. So this is Nana. So I have given clarity. Hope so. I have given clarity for the Abbas question and Aditya's doubt. Clear, ma? Now let me go ahead. Yeah. See, what is the basis to divide the elements into blocks? Differentiating electron. On the basis of differentiating electron, elements are classified into 4 blocks. Last electron. So that we can write the general electronic configuration. General electronic configuration of S block elements. S block elements. General electronic configuration of S block elements is NS1 to 2. NS1 to 2. N means number of shell, subshell. Either 1 or 2 electrons will be there. All of you note down this point. General electronic configuration of S block elements NS1 to 2. Next. In the same way, they found that group number 13 to group number 18. From group number 13, what is that? Boron. See, Nana. From group number 13, I am rubbing out this. One, two, three, 4, 5, 6, 7, 8, 9, 10. Yeah. From group number 13, see like this, Nana. From group number 13 to group number 18. This is 13th group, 14th group, 15th group, 16th group, 17th and 18th. Yeah. These 6 groups, if you take any element, you can observe the differentiating electron enters p subshell. The differentiating electron enters p subshell. All these elements, aluminum, silicon, phosphorus, sulfur, chlorine, argon, gallium, indium, thallium, tritium, germanium, tin, lead, quadium, selenium, nitrogen, phosphorus, arsenic, stibine, bismuth, pentium, selenium, tellurium, polonium, hexium. Yeah. Bromine, iodine, astatine, septium, krypton, xenon, radon, octium. Nana. These are totally how many elements, ma? 36 elements. Not helium, Nana. Helium does not belong to P block. Helium belongs to S block. Nana, listen carefully. Someone has left from online. You are going to be punished. Join back. See. So that very, very crucial chapter. Everyone must be till I end the chapter. Till I end the explanation today. Now come here, ma. See. If you suppose if you observe helium, generally helium is kept towards the P block elements, with the P block elements, but helium is not P block element. Helium is S block element. Only to justify the properties of helium. Helium is kept along with inert gases and P blocks side. Understand? So helium is not a P block element. Be clear about this point. Now come to the point. Totally these 36 elements, whatever the element you take and write its electronic configuration, the last electron enters P subshell. So that these elements are considered as p block elements. See Nana, suppose I am taking bromine. I am taking bromine, atomic number 35. I am writing in here. So far, your friend Aditya has asked one doubt. Accordingly, I will write 37. Out of 37 up to 18, I write argon. Argon compensates 18 electrons. Next to that, 4s2, 3d10, 4p6, 5s2, 5p5. Nana, this is about the electronic configuration of bromine. Totally 37 electrons. 18 plus 2, 20. Argon is equal to 18, Nana. 18 plus 2, 20. 20 plus 10, 30. Then, what it is? 3D, 4P. 4 plus P. 4 plus 2, 6, na? 5 plus 6. So, 5s2, 4p6. 1 second, Nana. 4s2, about the bromine. So, about the bromine, next to calcium, definitely 3D is filled. After 3D, 4p is filled. Don't mind 4p. 4p5. See now, 18 plus 2, 20. 20 plus 10, 30. 30 plus 5, 35. Atomic number 35. See, the last element, the last electron, that is the fifth electron, 35th electron enters p subshell of the fourth shell. My dear, all of you, be focused here. In case of bromine, I have randomly selected one element from these 36 elements, that is bromine. I wrote its electronic configuration. What did I find? The last electron of bromine atom, which is nothing but 35th electron, enters p subshell of the fourth shell. So, last electron is called differentiating electron. It enters p subshell, so that the element is called p block element. Like that, all these elements are p block elements. All these elements are p block elements. Okay. Lithium. Lithium 2s1, Nana, not 2p1, my dear. Lithium 2s1. 1s2, 2s1. Ganesh. Some Ganesh Reddy, you are telling that lithium, sir. Sir, can we write lithium? No. Lithium s block. 1s2, 2s1. Right. These are s block elements. Those are p block elements. Now, in between s block and p block, the elements are present. See, from calcium, atomic number 21, scandium 2, atomic number 30, zinc, Nana. Atomic number 30, zinc. Atomic number, krypton, this is 38, 39, Nana. Yttrium 2, atomic number 39, yttrium 2, 48, cadmium. Atomic number 57, 57, lanthanum 2, atomic number 80, mercury. Atomic number 80, 57 plus 32, 89. 89, actinium 2, atomic number, this is what? Unbium. Nana, not bium, not Telugu word. Bium, B-I-B-U-M, bium. So, unbium, this is trium, quadium, pentium, hexium, septium, octium. Yeah. So here, these elements, Nana, these 10 elements are here. Scandium to zinc. Scandium to zinc. There are 10 elements. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper. 10 elements are there. Yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium. Next, lanthanum, hafnium, tantalum, wolfram, tungsten, okay, rhenium, osmium, iridium, platinum, gold, and mercury. Afterwards, 89. This is actinium. Next, thorium, that is 90. Okay. Afterwards, actinium. Next to rutherfordium, seaborgium, 104, 105, anil, anil, septium, anil, actium, anil, nonium, nilium, unium, 111. This is the total periodic table. Okay. These elements especially are called, these elements, from scandium to zinc, from yttrium to cadmium, from lanthanum to mercury, from actinium to annunbayum. These elements are called D block elements, because of, if you lift any element, take any element and write its electronic configuration, you can find that last electron enters D subshell. So that these are called D block elements. Now, see one specific thing. This is lanthanum 57, but hafnium 72. There are, what is the gap? 14 elements gap. Actinium 89, rutherfordium 104, 14 elements gap. That means these 14 elements were kept. These 14 elements were kept below the main body of periodic table in the form of two horizontal rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Like this. Okay. Below the periodic table, this 58 to 71 in one horizontal row, and 90 to 103 in another horizontal row. Elements were kept. Elements were kept, See, 58 to 71 lanthanides, 90 to 103 actinides, placed below the main body of periodic table. This is the complete form of periodic table. Now, see, these 4 from 21 to 30, 39 to 48, 57 to 80, 89 to 112. These elements are called D block elements. D block elements. Yeah, from the D block elements only, first of all, 14 elements lifted and placed below the periodic table. Again, 14 elements lifted and placed below the periodic table. These are called F block elements, F block elements. So that here S block elements, first group, second group, S block elements, 13 to 18 P block elements. In between that, group number 3 to group number 12 D block elements. Within the D block elements, F block elements. Now I am going to conclude. See, here The everything I will tell you later, ma. Tomorrow also we have class. The rest of the things I will conclude, I will discuss with you tomorrow. But with respect to today's worksheet, what did you do? I am not going to discuss key. Key is kept and you might have done it. Or else today's worksheet, tomorrow I will discuss. Because of today, we are not going to upload anything. Istunamama. Today worksheet istunama. Okay. Yeah, today. But regarding today's worksheet, I did not explain. Only 30% I explained. Rest of the things I did not explain. So that do one thing. To do today's worksheet, go through the periodic properties, especially atomic size. Atomic size, prepare well and write the worksheet. Whatever your doubts are there with respect to periodic table or today's worksheet, tomorrow I will clarify. Tomorrow I don't want to extend the deep explanation because of today it is required. We need to do it. Okay. So being master, it's my responsibility to convey you all the facts. So I took some more time to describe it, but tomorrow I will go through the worksheet and that concept. Right, Nana? Yes, all the best.